What I hope to do in this video is explore the relationship between oil and gas prices. And you do see that there is a very strong correlation between how they trend. This right over here is oil prices quoted at a specific point on the planet. It is dependent on where you are. And as you can see, this is in US dollars per barrel. Early 2008, around $100, went up to 140, then came back down, and then it's been trending up ever since. Now it's about $100 per barrel. This is where we see the oil prices on a per barrel basis. And then related to that, you see the price of gasoline. And this is even more geographically specific because not only do you have transportation costs, but you also have very region specific taxation for oil and sometimes regulation. But taxation is the big part of it. But you do see it trends up when oil prices trend up, and then it goes down. And this is on a per gallon basis. And these are the prices right over here in New York. But they don't move completely lockstep. If anything, you see that the oil price on a per barrel basis is much more volatile than the gasoline price right over here. But there is the same general trend. When the oil prices moves up, this tends to move up. But it's not always in the same percentage, but there's definitely a relationship. Now, before trying to figure out when you pay, say, $4 at the pump, how much of that is oil and how much is refining and how much is transportation, let's at least kind of build up to that to think about just how does the oil even end up in your car, and then we can build up that price of the oil, or the price of the gasoline, I should say. So this right over here, you are probably familiar with these. These are oil rigs, two very different types. This is an offshore oil rig. This is a land-based oil rig, but they're both doing the same fundamental thing. They're drilling into the ground until they get to a pocket of oil, and then they will pump that oil out and try to transport it to the market somehow, first going through a refinery. Offshore is really fascinating. It really is an engineering marvel how they do it. It might be sitting out here in the ocean, and it will literally go to the bottom of the ocean, go to the seafloor, and then drill from there to actually get to the oil pockets. So it's really an engineering marvel, and you have to be very careful. It can be very dangerous working on an oil rig, and obviously if there's an accident on them, it can be an environmental nightmare like what we saw with the BP situation. But it is undoubtedly an engineering marvel. Now, once you have that oil, you need to get it to a refinery so that that oil can be broken up into its useful parts. And the way that it's typically transported to a refinery is some combination of a pipeline or an oil tanker. This right over here is actually the Alaskan pipeline, and it takes oil from the very northern part of Alaska to the southern part so that it can then be put on oil tankers, which can then transport it anywhere in the world to refineries. It could go straight to a tanker. Actually, even some offshore places, you could use a tanker, or sometimes they even, if they're close enough to land, they actually might have a pipeline that will take it to land where it can go to a refinery or go to an oil tanker so it can be transported even farther. And then from there, it gets to a refinery. And so we can start to think about how the price of oil is built up before we even think about what a refinery even does. So let's say that the current price of oil, and I kind of rigged the numbers not to be too punny, to work out fairly well, but let's say that the current price of oil is $90 per barrel. $90 per barrel. So a barrel is equal, and this is just a units thing, a barrel is equal to 42 gallons. So if I say I have a barrel of water, I'm really saying that I have 42 gallons of water. And now all 42 gallons of crude oil do not turn into 42 gallons of gasoline. Out of 42 gallons of crude oil, you can get about 19 or 20 gallons of gasoline. For the sake of, to make the numbers easy, I'll just go at 20. 20 gallons of gasoline, and then the rest will be other stuff. The rest is other stuff. So 22 gallons of other stuff. And it might not even be 22 gallons. In fact, it won't be. Some of it is just waste. Some of it is byproduct. Some of this is actually used to fuel the refining process. So I won't, let me not write that number. So the rest is other stuff. Other stuff. So let's say, so this refinery is paying $90 per barrel when it gets it. So that incorporates what the oil producers are getting. It also takes care of the transportation costs to the refinery. And let's say, just for the sake of argument, that the refinery can sell, and let's say it doesn't even take care of the transportation network. Let's say there's people who are willing to buy directly from the refinery at the refinery. They're willing to buy gasoline at $3.25 per gallon. So the gas at refinery, at refinery, people are willing to spend, or the transporter is willing to pay them $3.25 per gallon. And so from this barrel, they're going to get 20 gallons of gasoline. They can sell that at $3.25 per gallon. So you're going to have 20 times $3.25, which is, let's see, 20 times 3 is 60, and then 20 times 25 cents is $5. So they're going to get $65 for the gasoline. And then let's just say, for the sake of argument, they get $35 for the other stuff. And some of this other stuff is quite useful. It's stuff like motor oil. It could be jet fuel. It could be natural gas. And it could be obviously fuel to actually fuel the refinery. And so let's actually start building this up right over here. So one way to think about it, so let me draw it this way. So the price, so we're up to $3.25 per gallon is what the price is exiting the refinery, what the refinery is getting for it. So let me draw it down here. So let me draw it like this. So let's say that this is $1, this is $2, and this is $3. And then they're getting $3.25. $3.25 would be like that. That is what the refinery is getting. And one way to think about it, it's not completely, because all of their profit isn't coming from the gasoline, but one way to think about it is the refinery, after refining all this barrel of crude oil that they paid $90 for, they're going to get $65 for the gasoline, and then they're going to get $35. They're going to get $35 for the other stuff. So they made a combination of, what is it? They made $100. They're able to buy this crude oil at $90, do what they had to do, and then they're able to sell it for $100. So one way to think about it is that, at least in this situation, 90% of what they're getting for it was their costs, but it breaks down between the other stuff and the gasoline, so it's not super easy to break down. But you can say, in this example, a good chunk of this was the cost of gasoline. A good chunk. And it's obviously depends how you account for it, but a good chunk of it, not the cost of gasoline, a good chunk of it is the cost of the crude. And this right over here, you could say, is how much the refinery actually makes. And that the amount that the refinery gets versus what it costs, so the amount they get for all of the products they produce versus the crude oil that they have to pay for, this margin, this is often called the crack spread. This is called the crack spread. And just to understand what a refinery is doing, it's breaking up that crude oil into its various parts. And it's actually a fairly simple, well, I don't want to say simple process. Obviously, when you look at a refinery, it does not look like a simple thing. But the idea for the process is fairly straightforward. It takes the crude oil, so it takes the crude, and it heats it up through a boiler. So right over here, the crude is getting really hot. This is the boiler, and the boiler is often fueled or usually fueled by some of the outputs of that oil. So this is fire right here, just to symbolize that it's getting hot. And then it goes into a distillation column. And the distillation column, that's why you see all of these towers right over here in an oil refinery. Those are the distillation columns. And so in the distillation columns, the different parts of the oil have different boiling temperatures. So the very long carbon chains in the oil have very high boiling temperatures. So as hot as they are, they're not going to boil. They're going to stay in their liquid form down here. And then the slightly shorter chains, they're going to boil and evaporate a little bit. But then as they rise, they're going to cool down, and then they might condense right over here. Then they can be pulled away in pipes. And then things that are even slightly shorter chains than that will go a little bit higher before cooling to even lower temperatures before going back into a liquid state. And then they can be collected over here all the way until you get to the very shortest chains, like the natural gas, that would be collected out at the top. And the gasoline that you put in your car, it might be collected right over here. From this. So you're breaking up that oil into its different parts. And on some of the other parts, this might be motor oil right over here, the thing that you use to lubricate your engine, not fuel your engine. You might have jet fuel up here. And you have a whole ton of other different, kerosene, all sorts of things you are able to take out of that crude oil. But anyway, let's get back to the gasoline. So the refinery got $3.25. Now we have to transport that gasoline. So let's say 10 cents for transportation. So this is at $3.25 right over here. So now we're going to have 10 cents for transportation. So that right over here is 10 cents for transportation. I'll just write transportation for short. And then it goes to the gas station. And as I mentioned, gas is heavily, heavily taxed. And it depends on what jurisdiction, what country, and even states within countries. But for the sake of simplicity, let's just say it's taxed at 50 cents a gallon, which is not that different from what is taxed at many states. So now we're at 50 cents a gallon. So that would be right around, so let's say, actually let me do a new color. I keep using the same colors over and over again. So let's say this is, so then it's 50 cents a gallon tax. So that is tax right over there going to the state and federal government. And so let's see, $3.25 is what the refinery got. 10 cents for transportation gets us to $3.35. 50 cents tax, so this is 50 cents tax, gets us to $3.85. $3.85. And then now we're at the gas station. They're essentially, it's going to cost $3.85 a gallon for that fuel. The gas station needs to make some money to pay their costs. The gas station sells you that fuel at $4 a gallon. At $4 a gallon. And so you might say, okay, the gas station, and that already seems surprisingly low, and that is actually on the order of how much gas stations actually make on a per gallon basis. You might say, hey, the gas station made 15 cents. $4 minus the $3.85 that takes in all of these other costs. But actually, a huge amount of that 15 cents actually goes to the credit card processors, because most people pay at the pump with a credit card. And that's why some gas stations like it, will give you a discount if you pay in cash, because of that 15 cents, as much as, or in general, around 5 cents of that will go to the credit cards. Will go to the credit card processors, credit card fees, I know this is getting messy, credit card fees. So the retailer will be left with about 10 cents. Will be left with 10 cents of margin. So anyway, hopefully that gives you a sense of how crude oil turns into gasoline, and when you pay at the pump, what is the breakdown for the different players and how much of the money is going to those different players.